Thank you, Tom. Thank you for inviting me to speak today on behalf of our cooperation with OPC. My name is Katherine Voss. I'm the Executive Director of ODVA. ODVA is a vendor organization that is similar to OPC in structure and mirrors functionally a lot of similar activities that OPC engages with in terms of standards development, certification, and promotion of the standards which we manage, but we're coming at it from the network side. And we have recently engaged in a cooperation to marry the OPC side and the network side around the concept of machinery. And today I'm here to introduce the scope of that cooperation and let you know that we will be working on this area in the future. ARC's World Industry Forum focuses on the challenges that industry faces and hopes to, through collaboration and sharing of ideas, to find ways to improve and solve pressing problems. One of the key challenges faced by machine builders and manufacturers is the integration of machinery with other machines, the plant and the enterprise. Today, I'm going to spend a few minutes introducing a cooperation between OPC Foundation and ODVA that focuses on the optimization of machine integration. This cooperation seeks to protect the existing investment in know-how and equipment while providing a platform for innovation for the future. A little bit about ODVA. I believe it was said OPC servers first started shipping in '96, and ODVA was founded in 1995 by several automation companies to actually bring the DeviceNet standard into an open, interoperable standard supported by multiple vendors, and to develop conformance testing for those standards, and to promote adoption of the technology. Today, our scope still does include DeviceNet, but includes a suite of technologies that are all linked by something called the Common Industrial Protocol, which is a media-independent producer-consumer protocol that is sitting on top of DeviceNet, Ethernet IP, ControlNet, and CompoNet. And it includes support for a broad range of automation applications, including control, safety, synchronization, motion, energy, network management, and information. The organization consists of approximately 275 entity vendor member companies. We are a vendor organization. We have approximately 15 technical working groups and more than 100 companies participating in those technical working groups to enhance our standards. We also operate conformance testing to certify multi-vendor interoperability in systems using our technologies, and we operate that conformance testing on a global basis here in North America as well as Western Europe and in Asia. In March of 2011, ODVA announced a new initiative around the optimization of machinery. And this initiative is aimed at the integration of manufacturing machinery with the industrial ecosystem. We decided that for the benefit of machine builders and manufacturers that ODVA should adopt an open and inclusive approach to this initiative, which included alliance partnerships with other organizations. And thus we reached out to OPC Foundation as well as Circos International to join us in this initiative to foster cross-collaboration on topics of mutual interest for machinery applications. In November 2011, we announced the first output of this alliance, which was the publication of a white paper. And this white paper, which has been available here at the forum, I was going to bring some today, but I noticed they're all gone, so I guess that's a good sign. Outlines our long-term vision for the optimization of machine integration, or OMI for short, as you will see in the paper. Today I'm going to give you a broad overview of this vision, What we are working on is something that we call in the paper a unified integration model for machinery that will provide standards and guidelines for machine builders and users to access data from their machinery and correlate it with data derived from SCADA and MES systems. What this means is that the issue needs to be addressed both from the network side and from the OPC side. Here's why. This is a graphic taken from the paper, and it is trying to depict machinery in what we call the industrial ecosystem, which, from our standpoint, this ecosystem encompasses three main domains: the production domain, the enterprise domain, and the power grid domain. Now, in this environment, today and for the foreseeable future, there will be multiple heterogeneous systems in this environment. And what we are trying to do is outline an interoperability framework that recognizes the reality of these multiple heterogeneous systems, and take a framework that encompasses these three domains. In this context, the vision recognizes the value of communication in machine control for production processes, while highlighting the possibility of viewing and using machinery information as a shared resource and a common currency across these three domains. Although machinery is essential to manufacturing, production professionals have not been provided with standard tools and guidance to simplify the integration of machinery in a holistic way. Our goal is that OMI will change this paradigm and will allow manufacturers to be able to gain visibility into the manufacturing information provided by machines throughout the layers of the production domain in a standard way. This in turn will help machine builders drive innovation while helping manufacturers drive significant productivity improvements. The approach of OMI originates from the key challenges faced by machine builders and manufacturers when looking to integrate machines. I think these will sound familiar to you. There is a proliferation of automation networks in machine automation. These networks are based on both standard and proprietary technologies, do not share a unified integration model, and are not interoperable at any layer of the OSI 7-layer model, making integration difficult. Secondly, the useful life of machine assets is long, which results in many installations with legacy networks, justifying the replacement of wiring runs, which can be difficult and keeps manufacturers from the opportunity to innovate, further complicates integration. Third, machine builders are motivated to provide a high-value machine which is differentiated from their competition on price and performance relative to asset turnover and not overall equipment effectiveness. And finally, to maintain machines, manufacturers need to give OEMs secure remote access to the information that is being shared for both machine-to-machine as well as machine-to-information systems, including MES and enterprise applications. In OMI, we are focusing on three key use cases: machine-to-machine communication, machine-to-supervisory communication, and communication connectivity. The first two of these use cases are most relevant to the cooperation between OPC and ODVA. Establishing standards for machine-to-machine communication will help minimize the time and cost of machine integration and reduce custom software and special hardware needed to differentiate and integrate different vendors' equipment. Establishing standards for machine-to-supervisory communication will permit manufacturers to consolidate and exchange machine information across SCADA and manufacturing systems to collect production data, assist in asset management, and report diagnostics and alarms. Both, most importantly, allow existing automation to incorporate functionality needed to realize new efficiencies in machine utilization, thus protecting the user's investment both in equipment and know-how. And I think this is really a big part of why this cooperation is important, because from both the OPC side and the ODVA side, industry has a significant investment in these technologies and an understanding of how to manage, maintain, troubleshoot, and apply them to new applications. And so what we're trying to do is take that existing know-how, agree on basically a common data model that can be shared between the network side and the OPC side, and thus eliminate the need for developing custom software tools to exchange that data and convert it into information. So the comprehensive approach of OMI will allow industrial consumers to treat the machine as a shared resource within and between each domain of the industrial ecosystem. We see not only a value for this as it relates to the interface to SCADA and MES within the production domain, but we believe that this also has a lot of potential for expansion into the areas of facility management with the power grid, as the visibility of machine states can be more available to that side of the industrial ecosystem domain. Ultimately, OMI will provide an optimized machine deployment and integration approach that makes it possible to dynamically share information in order to maximize overall equipment effectiveness. To learn more about this, the white paper is available at the OPC website, opcfoundation.org, for download. It's also available, of course, at ODVA. We expect to make another announcement pertaining to the scope of our technical work in 2012, Q2, and that will, of course, be available at the websites shown here. So you need to stay tuned at that point in time. The white paper itself is a vision paper, and the audience for the paper is business and technical leadership who are seeking to identify a roadmap for future innovations in the integration of machinery. On behalf of ARC and OPC, I want to thank you for this opportunity to present this white paper and the concepts presented therein. I encourage you to download it. It's a good reason to give your business card to whoever's collecting them, so we can send you a link for the paper. And I'm available for questions, I think, in the panel or afterwards via email, kvoss@odva.org. So thanks, Tom.
Thank you, Catherine. Thank you very much.